welcome welcome back. Today we are going to see the question that is 1129, the shortest path with the alternating colors, right? So let's read this question and try to understand this 1129 question. The question is saying that you are given an integer n and the number of nodes in a directed graph where the nodes are labeled from 0 to n-1. Okay, so number of nodes in the directed graph we have given, and that is 0 to n-1. Okay, means it is connected component we have, right? 0 to n-1 we have given. Each edge is red or blue in the graph, so that could be self edge and parallel edges. Okay, next it is saying that self edges and parallel edges, and each edge is a red and blue we have given. Now it is saying that you are given two arrays, red edges and blue edges, where red is fi, bfi, and blue edges we have vj, use, vj. Okay, we have given. So it indicates red edge we are given indicates that there is a directed edge from node A to node B in the graph, and blue edge is saying that directed blue is from uh, node U to V. Okay, correct. Okay, yeah. Next it is saying return a array answer of length. We have to return an answer of length n, return an array answer of length n, which is answer of x is the length of the shortest path. Is answer of x is the length of shortest path from node 0 to x. Okay, so all the element we have in the answer is the length of the shortest path, is length of the shortest path from node 0 to the given node, right, at that index, you can say. Next it is saying that such that the edge color, alternating color is along the path -1 exists. If not, so we have given this example 1. We have given number of nodes 3. Let's suppose we have given what 0 and 2, 0, 1, and let's suppose 2 we have given here. Okay, so if I'll say these 3 nodes we have given. Okay, so we have what 0 and 1 is one edges we have. Let me, okay, yeah, let's suppose 0 and 1 we have one edge, and 1 we have 1 to 2. This is the you can say uh, graph we have given, right, directed graph. So it is saying 0 to 1 means like this we have given, and 1 to 2 we have given like this. Now blue edges we don't have, right, means directed blue edge we don't have from U to B. Okay, next second is it is saying that uh, what next it is, this is the red line here, right, and this is the directed is from here to here, and this is a red one. Okay, you can say, and we have given, but blue we have not, we don't have given. So in this case, if we want to find the distance, right, let's suppose we have three things we have given, right, three x we have given, node node 1, node 0, node 1, and node 2. So answer will contain what? Answer will contain like what? Answer should have you can say node answer at, you can say at node 0. Suppose 0, node 0 to node x, right? So 0 to node 0, let's suppose node 0 to its distance, its own, right, is the length is what? Its own, right? From, you can say, from node 0 to node 0, what is what we have the length? The distance is what? Distance is 0, correct? That we have seen here. Next, if I want to see from 0 to 1, right? So node 0 will be 0 only, and if we'll go to node 1, so the distance will be what? This time we have this distance, right? So if I'll take this is suppose we have like this 0 minus 0, and we are saying that what we have here, sorry, what we have here, 0 we have, and in this case if you say the 1 minus 0, and that will come what? 1, correct? Similarly, if we check the distance between 1 and 2, it will come again what? This one. But if we'll take node 0 minus node 1, what it will come? So you can see that there is the distance from here to here, the direction is not here, right? 0 to 2 direction is not here, right? So 0 is coming to 1 and 1 is coming to 2, correct? So that's why it is giving distance -1, right? Why it is giving -1? See, we are we have given what? A directed graph, correct? All the direction from 0 to 1 and 1 to 2 we have given, right? And it is saying also that we have red and blue edges we have given. In this case, blue edges we don't have, correct? But what we have a red one we have, right? Red edges we have, that we have seen away now, that we have seen just now, okay? And our task is to return an array of integers, correct? Our task is to return our array of integers, that is answer. So if I'll talk about answer of x, so answer of x is the number of, so you can say, sorry, answer of x is a length of the shortest path from 0 to node 0 to node x, correct? So here node x is what? 0, 1 and 2. So what we have to do is color altering alternating alternate along the path will we have, or if don't have, then we will return -1, right? So there is no path between 0 to 2, and that's why we are returning -1, because the question is saying, right, if you'll read the very well, what is saying that answer of x is the length of the shortest path, right, from 0 to node x. It means you can say the edge color of alternate along the path that we have, right? And if not, then we will return -1, right? So if path doesn't have, okay, so let's understand little approach, right, what we should do. So approach, we can use BFS here, right? So see, if we want to find the distance, right, the BFS is the best approach to find the you can say distance, right? Why? Because the distance to find the BFS is, if you find the way, right, for any uh, you can say algorithm, right? So shortest path is the best way to find, right? So let's understand the institution. What the institution we have? So breadth first search is a good algorithm, right? And in this case, we have given a you can say array. Array we have given, and that is called node, right? So all nodes we have given, and its edges we have given, correct? Number of nodes we have given, and you can say edges we have given, red and blue we have given, right? So if we want to find the shortest path in the unweighted graph, right, we don't have weight, right? So if we want to find the shortest path in a unweighted graph, the property of BFS is what? The first time a node is reached during the traversal, it was reached in the minimal possible steps from the source, right? So the path from BFS traversal always have the least number of edges. So the breadth first search, what does it? We have a level-wise iteration in the graph, right? We used to do in the breadth first search. In the depth first search, we will take the one node and we'll go to its depth till the child, right? It will not end. But breadth first search algorithm, what does it? We used to do you can say level-wise iteration we used to do, correct? So some you can say level-wise iteration we will do, correct? And you can say uh, if and if we do the level wise iteration, right? So what will happen, it first find all the paths that are one is away from the source. Let's suppose we have some given ages we have given, right, like this. Then we will go to here is some we have, right, like this, like that we have given. Let's suppose these are nodes we have, right? So these are levels, right? These are levels. Here is also a point, right? So L1, L2, L3. Okay. So what will happen? It first we will find all the path that are in one edge. L1 in L1 you can say, right? And that is from the source. We can take from the source, right? Let's suppose this is the source, right? So we will go to, let's suppose from here in the L1 we will go either this way, we will go here, or either we will go this one. So first we will complete this L2 and then we will move to other, correct? So what we will do, we will find all the path on one is, and you can say from the source, and then we will find, then we will follow the you can say all the path that the is away from the source node, and we'll do the same again and again. You can say we'll follow the same way, right? So this way it allows us, the BFS, to, you can say, to find the shortest path in the terms of steps from source node to, you can say, to any other node you, if you want to go. So if we want to implement this, we will we can implement it with a queue, you can say. So we can use the BFS algorithm, like we'll do some modification, right? Whatever required. So let's suppose what we can take some examples, okay, and then we will start working on. Okay, let's suppose we have given here, let's suppose here we have given some steps we have given, let's suppose. Okay, so what we will do, take, let's suppose what we can take, we have given an example. Okay, this is one, let's suppose we have given two, then we have given three, right? So first we have given 0 node, right, and its all children is 1, 2 and 3 we have given. Next, let's suppose we have given 3 and it's given 4. Okay, these nodes we have given. So what we will do first, right, we will try to implement this in such a way, we'll go with the level wise, right? Level wise means first we will go this level and this level, right? So if we will want to represent this one, how we will represent this one? So this is our node 0, right? So node 0 is there, right? Let's suppose I'm talking about this one. Then what we have is children we have, right? What children is 1, 2 and 3, let's suppose. Next time we will not go further. What we will do? We have the, here we have, but we will not traverse. Next time what we will do? We have already traversed this one, then we will traverse to these three, 1, 2, 3. So first time we have traversed this one, now we are traversing this one, that's why I'm taking like this. Okay, so next time we will go like this. Okay, next time it will come, so we have traversed this one, these three we have already traversed, right? Now we will traverse what, whatever the data will have in this one, like we have here 3 and 4 we have, right? So we will traverse now this one. Okay, like this way we will traverse one by one, right? So if you have already familiar with the BFS, it's fine. Otherwise you can go do Google and will to find the basic understanding. Okay, so this problem says that let's understand, uh, you want to traverse from you can say you want to do traversal using an alternate color, right, along a path, so what we have to do in our BFS traversal, we must keep track of color, right, and which we visit the color node, we can say. Okay, so what we will do, we will use it to move to the neighboring nodes by traversing our alternate edges, colored edges. Okay, so in the context of, you can say, to a normal traversal, what we will do, we will move to each node in a visited uh, we will take in the visited node for the only one time visit. Okay, and like one node, each node should visit at least only one time, not much than, you can say, we can visit only one, you can say. So a node can be visited at most twice, right? In this case, it can be visited once from the red edge and once from the blue edge. In the BFS, what we used to do, we used to traverse the only one time, right? But our condition is changing, right? So what we have to do, we have our node should be visited, right? Only not one time, but at least twice, right? And it can be visited once for the red edge and another for the blue edge, as you can see here, the first one, right? So two things we have given, the blue edge we have given and red edges. So all the node will go through this one and another thing will go this one, correct? Now think that if we get the minimum number of steps required to visit a node for the first time, we visit it, right? And we may also need to return the same node using a different color edge than the one used in the first visit, you can say, correct? So we then proceed to cover our neighbors, and we may now have our cover during the first visit, that will be due to maybe some color constraint, right? So what we will do means, I want to say that, like we want to get the minimum number of steps and required to visit a node for the first time, you can say. So we will visit that node, right? And then what we will do, we may also need to return the same node using a different color edge than the other than the one used for the first visit, you can say. So what we will do, we then proceed our you can say neighbors, right? And we may not have to cover during the first visit due to some constraint, you can say, right? Color constraint. So what we will do, we need to keep track of how many steps we have, right? It will take to get each node. So we will use it to update the answer for the node when it was first visited. So what we will do, uh, we will take a BFS queue with a integer, you can say triplet, right? And the first value would be our node, and the second value would be the number of steps we will take, right? So let's suppose the queue will contain two things. First, what it should take, the you can say this is our, let's suppose this is our queue, okay, like this. So the first value would be our node, the node we have given, whatever node we have, that will come, and the second would be the number of steps used for, right? So number of steps you can take, okay. So two things we will take, right, for the BFS queue, right? You can say, okay, this BFS queue we will take, right? So BFS queue will be an integer triplet, right? And we will take the first value would be a node, and second value would be number of steps that is used so far, and the third value would be color of is, right? So if we'll take here, you can say color, right? So the color of is we will take is color, you can say, or color of is, you can say, and so that the color node we will the current node reached, that we will take here, right? So what we have taken, the first node we have taken, first value we have taken node, second we have taken number of steps, and third we have taken what, the value, and third value we have taken what, the color of the is through which the current node was reached. Now we will use the queue to perform the BFS, right? And from the current node to the neighboring node while reading to the, you can say, moving to the color constant, right? So what we will try to do after implementation, what we should do, we will create an adjacency list, and then we will try to implement this one. Okay, so let's go to the browser section of this program and we'll try to implement through this one, right? So before that, what approach we should use, right? So first we will take one adjacency list, right? Adjacency list we will take. Then so why we will take the adjacency list? See, so that adjacency list will contain all a list of pair of integers such that adjacent nodes, right, and contains all the neighbor and uh, neighbor and its color, you can say. That combination we will take, and then we will create you can say uh, answer array, and then we'll try to add into there. Okay, and we'll take one visit array, and that will take node and color, and we will try to iterate over that using the uh, queue that we have taken for the triplet values, right? Then we will take and we will find the, you can say, queue value and sorry, distance, and we will loop on the neighbor and color, and then we will return the answer. Okay, so let's go to the browser section and we'll try to implement the code. Okay, let's go. Red is and blue is and the number of nodes we have given, as we have given the example, right? So first of all, what we will do, we'll try to create adjacent list, and then we will move on there. Okay, so we'll take a map, and map will contain what? Two things. First it will take integer, and another it will take what? List of you can say neighbors, right? So we have list, and this list will contain a list of integers, correct? List of integers it will take, and that is our adjacent adjacent, right? And it will contain map. This map will contain what? Our list integer node and its adjacent list, right? So this is our new has map. Now what we should do, we will take a loop, right, and we will move on to the red one, right? Red edges that we have given. So int, you can say this is our that 2D array we have given. So we'll take 1D array and we'll say our red red edge, red will take, and it will come what? From here, right? One by one we will get into the red one, and then we will do this one. Okay, now what we will do, now we have our red one, so we will put onto the adjacent one, right, that we have created this one. Now take this one and say there is a method, right, compute if absent, this one. So we'll take this one and we'll add here. The first we will put the age at this one, right? What is the age? You can say at at the red edge. We will give the name red edge, so we will understand. So this is our red edge, right, from the we are getting, and at this is, this is nothing but what we have, this one, right? So this age will contain some data, right? So at first we will add the node, and then we will add its value, right? So the value will, you can say, will take k, and we'll say what we have already and we have taken, right? So we'll take k or item, you can say, and we'll go to map its with the lambda expression. Okay, so this list will contain a list of integer, right? So we can put here the list of integer like this. Okay, now this is done. On this we will add you can say the list, right? we will move into the you can say into the we will make all the edges you can say neighbors into in the form of arrays, right? So we'll make arrays dot as list, yeah, and here we will pass our the as we have at 1 we will get a list, and that list will be get converted right into arrays. This is done. Then what we will do, we'll do the same activity for our we can say blue one, right? Now this time we will pass the blue edge. You can take this as well now, right? No need to change the variable, but for the better understanding we'll say blue is, and we'll put blue here, then here, right? First we will add the blue node and blue edge node, and then we will add the its we can say its array, its array of neighbors, right? And then we'll pass at 1 at the index that will go 0, and this will come at 1, right? Then we have done, right? So this we have already now we have completed this tool. Okay, now what we should do now, it's very important. What we will do now, we'll try to find we can say array, right? Till now what we have did, we have created an adjacency list, right, that contains a list of pair of integers, right? And uh, this will take adjacent of node, and it contains the what uh, node and you can say neighbor and color, right? Now you can say in the form of neighbor and color. Now we have neighbor and its color we have, right? So the neighbor is the neighbor of node, and color is the denotes the is color of the you can say nodes, right? That connect color and node, right? It's neighboring colors. So we will use we are using what 0 for the red and blue for the here, right? For the one. So this is blue and this is red. So make sure that you will understand. Where I'll put 0 denotes you can say the red color, right? Red color, right? And if we'll talk about here 1 denotes what blue color, correct? See why I'm taking like this 0 and 1 in the form, so that we will understand. We will say this is our color, right? So actually, and the adjacent, this adjacent will store like this. See, this is our adjacent, right? So this will take one node. Let's suppose this is our node. So this node contains two things. If you check this node, so it would contain two things, right? It contains the neighbor of node, right? In the form of what? We'll pass two things, our neighbors, right? You will say neighbors, right? And another will pass our color. So that's why I'm passing what? This is our node. So at this node is at 0, right? We will have something, right? And here we are passing what? A list of you can say a list of neighbors, right? So list of neighbors contains what? Like this. We are passing array in the form of array. We are passing, sorry, in the form of array we are passing, and we are passing the color, right? I think you understood, right? So now all the variables and you can say our adjacent list has been initialized, right? Now we will create an answer, right? We will try to find the answer. Uh, we'll take -1 with the initial values, where answer of I is the you can say answer of ith node, you can say, right? So answer will take answer, and it will take what? Answer of I will take the ith node of the value, right? And we'll say initial value will take as a -1. Okay, so let's suppose uh, we'll take one 2D array. We should take 2D array, and this is our nothing but our answer. Okay, so this answer will take the number of you can say size should be equal to the number of nodes, right? As you have seen the output, right? So it will contain like this. Now what we should do, we will fill the array with -1, right? That we will do. So answer we have, so there is a default value we have to fill. So arrays can do this work, arrays dot fill, and will pass what, another will pass answer where we have to fill, and the default value will fill here, right? Now what we should do, this thing we have done. Now what we will do, we will create a 2D array of visit array, we can say, in which we will store like this. Visit will take a visited, right? And visited will take visited node, you can say. It will take a node, and another it will take what, color, right? So let's create. Actually this visited node will take node and color, and it says that like node has not been, node has yet, you can say, visited, right? Using the this color, this node has been visited by this color, you can say, right? This node has been visited by this color, right? If you want to understand, node visited by this color, right? So for that, what we should do, we'll take in the boolean form, right? Boolean, and we'll make true and false like that, right? So we'll take boolean and say this is our visited node we have, and we'll take node and color we'll take. So that, let me initialize this. This is called boolean, and for that we'll pass like this, right? So we should pass one number of nodes, we'll pass n, and color is only 2 we have, 0 and 1. Now what we will take, you can say we'll take a queue where we will do the performance of BFS, right? So let me create one here. I will take queue, and this queue will contain array of nodes, right? I'll take this one, and we'll say this is our, sorry, okay, and then we'll pass our what, new linked list. I'm sorry, L should be in the capital. This part is done, correct? We have taken queue. We'll take the we'll take the array of the nodes, right? And we'll do this performance, right? Now we should what we should do, right? We will create we can say we have created this queue, you can say queue of triplet, you can say, right? So to understand, sorry, triplet, the triplet, you can say queue we are saying, right? You can say a queue of triplet, a queue of a queue of triplets, you can say, right? We will create that, we have discussed, right? We will take three things, right? The first we will take the, you can say, three integers we will take per triplet. First we will take current node, let me write here, triplet. First it will take one, it will take what, the, you can say, the current node will take, the current node will take, and second what we will take in this one, we will take the steps, number of steps, right? And third we will take what, number of steps, then we should take the color, right? Color will take, third will take color. Okay, as we have already discussed this one, right? So three things we will store here in this queue. Okay, here you can say. So why we are taking like this? See, we want to create a queue or triplet because it will save three integers per triplet. The first, the current node. Second, we will take number of steps taken to visit the node, right? And third, we will take the color of the previous edge that we have used, right? So this color is nothing but our, you can say, the color of the previous edge, right? Number of steps, you can say number of steps uh, taken to visit the node, right? That, and the current node, you know that, right? So current node will be the current node. Now what we will do, we will take node 0. Node 0 has 0 steps, right? So no specific color we will take for that, right? If you want to say uh, node 0 has 0 steps, right? Node 0 has 0 steps and no specific color we have, right? No specific color we have, uh, right? For visited. So we will use, so we will put -1 for that as a color, I can say as a color. We don't have the color. We also visit, let me say, like, we'll say visit ted and we'll pass 0 at 0 and will, 0 or 1, you can say 0 and 1, and we'll say true because we have visited this one, right? Because visiting 0 node against it is a pointless, we will not do anything else, right? Now what we should do, this part is done. While the queue is not empty, right? While queue is not empty, that work we will start now, right? So let's do here and we'll say while queue is not empty, right? Now we'll say queue not empty is a method, and we'll say here. Okay, so while queue is not empty, we will remove the first element of out of the queue to obtain node, steps, and previous color, right? What will take, sorry, we'll remove the first element and for the queue to obtain what, node, you can say. Then we will take steps and previous color, right? Three things we will take. How we'll do that? Let's do that thing. So we will have our queue we have already, right? So this is our queue. We'll do dot poll. So we have removed one element from the queue and we will store on you can say a storage, that is element will take as a element, one element we will remove, right? So we'll at a time one element remove from the queue and will store on this element, and then we will try to uh, find its all the things, right? Steps, node, and color. So how we'll get the steps, node, and color? First, let's suppose we have our node, right? So node is nothing but our element at 0, right? Three things we will get: element at 0 is node. Second, we'll take int steps, and steps is at what? Element at 1, right? And third, we'll take int you can say previous color, and is nothing but element at 2, correct? 0, 1, 2 will take. Now these things has done, right? So first we have removed the first element out of the queue, and then we will we have got the node, steps, and previous color. Now we will loop through all the neighbor and color pair in the adjacent node. So if the neighbor has not been visited with the color is, and then we will do what? Color not equal to previous one, right? So let's do it here. Let's suppose what I'm taking. First of all, we should check one thing, that is if the adjacent we have taken, right? Adjacent, yeah, adjacent we have taken, dot we have taken, will take contains, and will the say if this node is not there on the adjacent. First of all, don't do anything and jump from here, continue your work, because this is not here, right? So to do that, first of all, what we should do, we will have our adjacent, adjacent, right? Adjacent dot we will do no, get method, right? From the map we are getting, we'll get the node, and on the get we will return what? We'll get a list of integers, right? A list of integer, that is nothing but our all the neighbors we will get, right? Neighbor. Okay, on get we will get this neighbor. Now what we should do, so we will loop, you can say, on this one, and let's do it. First of all, what we should do, we will get a neighbor. Let's suppose neighbor we have, and this is our single neighbor we have. So what we will do, we'll do neighbor, and we'll pass get, and this get will take our at 0 we will get some neighbor node, right? And then we'll take one you can say color, this is a neighbor node, and this is our color. I'll take node, and this is our color. Okay, so color will also get at neighbor list we have, sorry, neighbor list we have, right? And on that we will call get method, and we'll pass 0, then we will get from the list, right? And we got our neighbor and color, right? So neighbor is at 0, sorry, color will be at 1, right? Then we will check if this is a visited color or not. So for that, see what we are doing, we are looping all the neighbor and color pairs in the adjacent node, node of you can say node in the adjacent, and if the neighbor has not yet visited with a color is, right, then we will check if color not equal to previous color, that we will do. So if not visited, at what? Neighbor node, right? If this node is not visited with this color, right? If this node is not neighbor node is not visited with this color, and the color that we have got not equal to what? Previous color, correct? Means our node is not on the visited node and color is not equal to the previous one. Then what we will do, first of all we'll make a condition if, and we'll say answer contain or not, right? So that will say answer of this neighbor node is what? If equal to -1. Then what we should do, we will increment our answer, right? You see previously this answer contains what? This neighbor node, right? This neighbor node we have some value will have that, and we'll take the steps, the total steps we'll take, right? So we will have our steps we have, right? Already have, right? We have steps, right? So all the steps we have, and then we'll add the answer value, right? Now if not, that is not the case, right? If we don't have, no need to do, I think leave it. Okay, Then what we will do now, then we will visit our make it visited. If it is not visited, right, then we'll take this neighbor node and its color, and we'll say make it visited. Now you are visited, and put onto the, you can say, our queue dot offer. So we put onto the queue. How we initialize this? This is an array. Will pass onto the first we'll pass neighbor node, then we'll pass our total steps. Total steps, current step is +1 plus steps, and then we'll pass our color. Got it? So this node neighbor node has been visited now, right? So once this is done, we have completed our for loop. This is done here. This is while loop completed. Yeah, while loop completed. Here we should return, right? Now return what? The answer that we have created. Let me zoom out. Let me check once more. So what we have taken here, we have taken neighbor nodes, then we have taken color, right? If it is we have red color, then we will add. If we have blue color, then we will add. For that we have already initialized the adjacent. Now we will take answer, we will initialize the answer all fields with -1. Then we will take visited, and another will take the queue, right? If visited and queue is there, right, then we'll go to the queue and we'll check everything here, right? Okay. See, one thing we have lost here is that how we'll find the queue value, right? If queue is not queue, if queue is empty, correct? So for that we should take three things, right? We have not taken the color. Yeah, this one we have not taken. These things we have written this here, like we will take triplet, one number of node, steps, and color that we have taken, right? So after the queue, what we should do, we should take let me do like this, right? We have already here, right? We'll do this one. With these initial steps we have not taken. So initial steps will take our neighbor node is nothing but our, we'll say 0, first node. Initial number of steps is for 0 is 0, that we are talking about this one, right? We have written here but we have not performed, so we should say this step is this for this one. And I should put this up so that there will be no confusion. Okay, let me put here. Okay, now we have added on the queue integer 0 0, and then we have taken for color, we have to take -1. We'll put -1, that we will do. Now what we should do, this is done. On the queue we have added, right? So we have to initialize our answer also. So let's say answer we have at 0 index and 0 node, we will put what equal to 0. We are not have anything. Now we'll say at the visited at node 0, we'll add the color, that is our nothing but 1, and we'll say its color is let me do equal, will make equal for color blue and red, both is true, both color has been visited. Now if we'll try to run, it should run. Okay, so I'm getting Java null pointer exception answer, right? But at the time of boolean, right, we have taken previously what boolean like this, right? But it should be what in the boolean object, it should be boolean b, right? So if you'll update this one boolean b, then it will work. Okay, let me submit this one. Yeah, thank you guys, thank you so much. If you like this video, please hit comment and subscribe this channel. Thank you so much.